In the first part of this presentation, we already had the introduction of matrix application and cryptography. Now, let's have another example of encoding a message using matrices. Let us again define the term cryptogram. Cryptogram is a hidden message written according to secret codes. This is derived from the term cryptos, which means hidden. To begin, we need to assign numbers to each letters in the alphabet using the character keys. We will use the following correspondence wherein letters A to Z correspond to numbers 1 to 26. A space is represented by 0 and punctuation mark is ignored. So let's have this example encoding a message using matrices. Write the cryptogram using message "Meet me Monday." So the first thing that we have to do is to express these words numerically. So for the message "Meet me Monday," we have to use the character keys as mentioned earlier. So we just have to look for the numerical equivalent of each letter. So for M, as you can see, we have 13. For E, we have 5, another 5, and so on. So for D, we have 20. So since we have space, we have to write 0, and 13 for M, 5 for E, another 0, 13 for M, and for O we have 15, and which is equivalent to 14, and D we have 4, A which is equivalent to 1, Y is 25. And though we still have period at the end of the message, as mentioned, we have to ignore any punctuation mark because there is no numerical equivalent for this. Given the numerical equivalent of each letter taken from the character key, the next thing that we should do is to write the number sentence as message matrix. You have to remember that since you are the one writing the message or encoding the message, you can write the matrix in 2, 3, or 4 columns. But for this example, let us write this into a matrix with 3 columns. So we have to divide this by 3. And then write this in a matrix form. We have 13, 5, 5, 20, 0, 13, 5, 0, 13, 15, 14, 4, 1, and 25. So as you can see, we have a missing element to complete this matrix. So if you do not have enough numbers to form a matrix, we can put 0 in the remaining space of the column. So we can just put 0. This is now our message matrix. And this is sometimes referred to as uncoded matrix. For our third step, we have to select any square invertible matrix called coding matrix. When you encode messages, you can use any coding matrix of your choice. But for this time, let us use this matrix A as our coding matrix. Now we can multiply the coding matrix by message matrix. But as you can see, the message matrix is written first before the coding matrix. We cannot interchange the order of these matrices because matrix multiplication is not commutative in its nature. Now, multiplying message matrix and coding matrix will give us the result, which is our coded matrix. Here is now our coded matrix. Lastly, we have to write these numbers in the matrices or these elements by column or in number strings and then send this to our recipient. This will become our cryptogram. So in this case, we're just going to write 13, negative 26, 21, 33, 33, 53, negative 23, 18, and so on until 77. So there you have our cryptogram. So that's all for encoding message using matrices.